Morning, everyone. This is Jenny from IT department. In this lecturer about operating system, course outcomes of operating system. Course outcome one: understanding the scheduling algorithm and process synchronization. Course outcome two: analyze and contracts deadlock prevention and avoidance algorithm. And course outcome three: compare and contrast various memory management schemes. Course outcome four: understand the functionality of file system, input output system. Course outcome 5: compare iOS and Android operating system. Unit covered. First unit is introduction. Second unit about process management. Unit 3 memory management. Unit 4 storage management. Unit 5 virtual machine and mobile operating system. Now, so in second unit, first concept is process. So in this process concept, what is process concept? Process scheduling and includes operation on process, cooperating process, inter-process communication. First one, what is process? Process means the programming execution. Yeah, while executing the program, it will change the state. So now we can see the different states in process states. New state, running state, waiting state, ready state, and terminated state. New state means the process is being created, and running means instructions are being executed. Waiting means the process is waiting for some event to occur. Ready means the process is waiting to be assigned to a process. Terminated means all the process are completed, the process has been finished the execution. Then diagram of process state. The diagram, the, dia- the diagram representation. So first one, new state. New state. Then first admitted the process. Now ready state. It's ready for execution. So waiting state means coming to an IO event. So if for IO that time the IO event completion, sometime waiting. So it will complete that is the program will be running. So once completed the execution process, the process will be terminated. Then process control block. So process control block, inside the process control block, process state, program counter, CPU register, CPU scheduling information, management information, accounting information, IO status information. Process statements, file status, program counter means it will be the next instruction of the data. Then CPU register, CPU program, CPU register. Then scheduling information. What scheduling? The CPU will some scheduling criteria. For first come first out scheduling. The shortest job first round robin like this. Then memory management information. Memory management information means the program the which process is now in memory and how many memory occupy in the process. Then accounting information also this also how many memory occupy allocation, deallocation, all these information in the accounting information. Then IO status information. Then process control block. So process inside the process control block, there is a pointer, process state, process number, program counter, registers, memory limits, list of open files. All these information available in the process control block. Then diagram. So diagram representation. First process P1, process P0. Left side is process P0 on executing the program. First save stated into program counter 0. Any interrupt or system call coming means it will complete this one. Interrupt means IO waiting. It will complete on and process P1 completed. At that time, process P0 will be ID. Then reload the state from PCB program counter 1. Then second one, um, save stated in the program counter P1. Save program counter P1. Then reload status from program counter 0. This also at that time any waiting for resources, the CPU will be idle. So once complete all the process, it will be executed. Then various queue. There is a ready queue, a device queue. So all these queue are available in the process. The diagram representation, ready queue, IO device queue, process control blocks. So ready queue contain process that are main memory, ready to execute, waiting for CPU. Head is first process in the queue. Tail means last process in the queue. The boxes are PC program counter B7, program counter B2, program counter B3, program counter 14, program counter B6, program counter B5. All the represent different process. These are connected like a linked list. When CPU becomes free, the process at the head gets a CPU. Then IO device queue. IO device queue has own queue. In the IO device queue, magnetic tap unit 0, disk unit 0, terminal unit 0 are. Each device queue has a head, tail, list of PCB waiting for the devices. And then what happens when process request IO? OS removes it from ready queue. It placed in a disk queue and waits that a unit IO complete. After completion, it moves back to ready queue. Then linked list structure. Head means it's a form a linked list structure. Head means first element, tail means last element. Then P1 using CPU, process 1 is using, for example, we have a three process P1, process 1, process 2, process 3. Process 1 using CPU, process 2 waiting for disk, process 3 waiting for keyboard. Then P1 is ready queue for running, P2 is in disk queue, P3 is in terminal queue. Why this important means manage multitasking, perform scheduling, handle multiple device, perform context switching. Then this program representation of process scheduling. This diagram represented ready queue, CPU, that is running state, input queue and output queue. Ready queue, process waiting for CPU or in the ready queue. Scheduler select one process. It moves to the CPU running state. While running in CPU, it IO request will, if the process needs input or output like it is keyboard, it makes an IO request, it moves to the IO queue, it waits until IO completes. Time slash expiry. So, time plus expiry means in round robin scheduling, each process gets limited CPU time. It time finishes before completion, process is moved back to ready queue. Fork a child. So, if a process create another process, parent continues execution, child process is created, child may enter ready queue. Wait for interrupt. So wait for interrupt means the process wait for an event. It enters waiting state. When interrupt occurs, it gets back to the ready, running or waiting ready. Then interrupt occurs. Interrupt signals into CPU. Waiting process moves back to ready go. For example, P1 starts running. It records disk. It moves to IO queue. P2 runs. Disk finishes. P1 goes back to ready queue. Then schedulers, we have the three schedulers: long-term scheduler, short-term scheduler, and medium-term scheduler. Long-term scheduler is a set of jobs. From this set of jobs, it will be some part of it will keep in the ready queue, and some sets will be kept in the device queue. So inside the set of queue and middle queue, that is called a long-term scheduler. And short-time scheduler, select a process should be bought in the ready queue. Short-time scheduler, select the process should be executed. Next and allocate CPU. Then addition of medium-term scheduler. Swap in, swap out. So swap in parcel executor, swap out process. So it's a ready queue. Ready queue is now ready to execution. So need to any IO devices. The waiting queues. It will be waiting for some process, and once completed all these process, it will execution. Then short time scheduler is invoked very frequently. It will be milliseconds, must be fast. Then long time scheduler is invoked very infrequently, that is seconds or minutes being. It may be slow. Short time scheduler may be fast. Process can be described as either CO, IO, input output bound process. That is to spend more time doing IO than computation, many short CPU bursts. CPU bound process spends more time doing computation, we very long CPU bursts. Thank you.